Hi, this is Miss Logan. Today I'll be giving a flipped lesson on electric fields. So how do we even know these electric fields exist? Well, we can't see them, but we know that fields are acting upon us. One of the first examples that we know is gravity. How are we able to stand on the ground? How are we able to throw something and come back down? We know there are invisible forces that have an impact on us, but we can't see. So just like gravity, electric fields have impact over us, however, we can't see them. Any charged particle will create an electric field. If I put in a charged particle in that electric field, it will feel some type of force. So for an example, I have a positive field. So this is when I don't have any charges around. For a positive proton, this is what it's going to look like. We see the arrows are pointing outwards. However, for a negative particle, we're going to see that they're going inwards. We'll talk about how we can tell that in a moment. So when I put these together, we are going to see something predictable. If I have opposite charges, we are going to see the field lines are coming together. My positive is moving towards my negative. They are attracted to each other. But if they are the same, like we would expect, they are repelling against each other. So my field lines aren't touching. We can also see this through this example down here. This is similar to the eye ring fillings that we saw in our video. If I have two charged plates, we're going to have something very similar happen. We're going to see that my field lines are attracting towards each other. Remember, my field lines are also coming out of this side, but they're actually looping all the way around. So electric field strength is represented by the number of arrows. So the more arrows we have, the more electric field strength that we have compared to others. So what is the equation that we can put with this? Our force, which is in newtons, is equal to the charge times the electric field. Remember, our charge is C, which is also called a coulomb. We used this before. Our electric field is Newton over coulombs. We're just dividing the two. How do we get that? I have F equals QE. If I divide Q on both sides, my electric field will equal force over Q. Remember, my force unit is newtons, and my charge unit is coulombs. Let's do a problem. A positive charge has a magnitude of 2.4 times 10 to the negative 8 coulombs, experiencing a force of 1.5 times 10 to the negative 3rd newtons. What is the strength of the electric field at that position? So let's use our equation, QE. So my force is equal to 1.5 times 10 to the negative 3rd newtons. My positive charge, remember charge is Q, is 2.4 times 10 to the negative 8 coulombs. So let's plug that in. I have my force and my charge, and then I'm solving for E. So for my answer, if I divide, I'm going to get 62,000 newtons over coulombs. So you may be wondering, how do we actually figure out about charges on objects? Well, if we use Millikan's oil drop experiment, we can figure out how much charge there is. So what Millikan did is he sprayed oil in fine droplets into this device. There's a pinhole right here that is X-rays to produce a charge on the droplet. So the oil that's charged fell through here. Now there's, as you can see by the positive and negative arrows, we had the oil drops actually starting to move in space in their terminal velocity, or their highest velocity that they could get. So what did we figure out from this? Well, we actually could figure out the charge of the electron. Let's go to the next slide to see how. So here's our free body diagram, and this is the oil droplet while it's in its chamber. I have my positive and negative here. So I had mg going down, which is our force of gravity, and then I had my force drag also going down. Remember, it was at its terminal or final velocity, so it was going as fast as it could. What was pulling it back up? Well, we had the charge of an electron times E, which was, remember, our electric field strength. They know this electric field strength because we have these two plates here. They could actually figure that out. So because of this, we were able to figure out the charge on the electron. Let's do one more problem. So a balloon with a charge of 4.8 times 10 to the negative 7th coulomb is suspended in an electric field with a strength of 400 newtons per coulomb. What is the mass of the balloon? So let's plug this in. We have F equals QE. We know from Millikan's experiment that F is also equal to mass times gravity. So let's plug in and solve for our mass. So if I multiply and divide this out, I'm going to get my mass is equal to 0.000019 kilograms. So please work on your Google form for credit and bring any questions to class.